morning, everyone. Thank you for coming today. It has, for most of my career, maybe like yours, the input was well defined and no one questioned whether it could happen or not. It was just a matter of how long, when. Latterly in my career, the input is defined by idiots who write COBOL, and the question of whether it can happen or not is a matter of if, and it's my job to turn it into when. That's how GCC got to have COBOL in it. Today, I'd like to talk about another if versus when question, and to talk about a way that we could use GCC to encourage better building of tools. Jose the other day spoke about how we don't create complex tools for complex problems. And I have been living with simple tools for complex problems for far too long. I'd like that to change. I used to use better tools for less complex problems. So I come in a little bit disappointed with where we are and determined to make it into something else instead. I'm going to describe what I mean by that. I'm going to show you a tool that I used 100 years ago that did a better job than anything we have today. I'm going to show you a proof of concept built on tools that we have now that we could use to build better tools in the future. And I'm going to ask you to help me do that. And I'm also, part of that is trying to figure out how to extract the information I know we need, but have for sure, into a place where we can use it better. Those who do not understand the past are condemned to repeat it, right, Satyana? The software crisis, this is the era of the go-to is considered harmful letter. That wasn't Dijkstra's title, that was given to him by the editor, but it was the beginning of the problem. When I was a boy, we had case tools, we had data flow diagrams. They later evolved into UML, which is a useless structure. We had the Smalltalk class browser. We had ways to navigate relatively small systems better and describe them. And something happened in the 1990s that destroyed most of what was building that, and it was never recreated. Microsoft dropped C++ for a while. It gave GCC a chance to catch up, was an important opportunity, I suppose. We watched X11 stop being developed. Maybe you think it's still being developed. I think it is being undeveloped. Display PostScript didn't ever become a thing. Sun Microsystems, Digital Equipment, Bell Labs, the park, all these things existed and stopped being useful for carrying things forward. I think the people who were creating academic foundations for our tools are either being ignored or turned to other directions. And maybe it's because nobody pays for tools. I don't know. I've worked on Wall Street on code bases that make the Linux kernel look pretty small. And they didn't pay for much in the way of tools. So I work in C++ to create a COBOL compiler. But I don't have any C++ tools specifically. I don't have any C++ tool that'll tell me how to find the elements. I can't even find a tool that will tell me, that'll let me find the name variable of a structure whose type I've defined, specifically to that structure. I have lots of structures that have the word name in it because I write a compiler, and but the different kinds of names are significant, and anyway. So what do I use? I use cscope. Everybody uses cscope. I use ctags inside Emacs. Those are my two go-to ways to find stuff. In that prior life, I used a thing called OpenGrok, which is essentially a giant web-based grep kind of tool, but it doesn't really understand a lot about C++ syntax. I've used Visual Studio, which actually has a pretty good system for navigating the source code, if it's not too much. If you hand Visual Studio 1,000,000 lines, good luck with that.
Another similar tool, Sedet and the Semantic Bovinator, dead as of about 2009.
Right.
So,
right. In researching this talk, I did a little bit of background work. I found tools that claim to do stuff, but ultimately they all boil down to the same thing. We use the cscope database or we use etags database. And as I said, they just on a big system, they just simply don't work.
If I may, I should mention LSP, the Language Server Protocol, and CLANG-D would be, I think, I guess the big thing in this space.
Yes, I think so. So the Language Server Protocol is an access method. It's not a system for organizing the information.
Protocol.
And I actually tried to do this with Clang upon a time, but when I was, 15 years ago, so maybe not quite as skilled as now, I'd like to think. But I don't know what the limitation there is. In answer to your point, I would say if somebody will show me what I've done today using a different system, we'll start from there. That's good. So anyway, none of the tools I use or have found will distinguish between standard find and standard map find. I've got structures, as I said, with members whose name is name. And I'd like it, but whether it's a file name or a variable name or a type name matters. And I can't find specifically any one of those things. Does anybody here use a tool that can find out where operator equal is being used, overloaded? Do you have a tool that will tell you where the address of your variable has been taken or where your pointer is being dereferenced? Do you have a tool that will understand things that aren't written down, like auto? Can you constrain it to particular files or scopes? All of this information is in the parser. It's right there, standing up in memory. All that needs to be done is commit it to some place where we can interrogate it. This is the problem. We can take the parse tree and stick it into the database and create a comprehensive set of information across all the files you're using, and then ask questions about what's being used and how. We should be able to constrain the question that we're asking to certain regions of the code base. When I'm working on my system, mostly I want to work on the front end of the COBOL compiler. But sometimes I have to ask questions about, say, diagnostic information. So I'd like to extend the realm of my question. We should be able to use a tool that doesn't fall over when you hand it a million lines of stuff, because the big problems are the important ones. And I don't see any particular reason. I'm talking about C++ because I know it quite well. But I don't see any particular reason that this needs to be constrained to one front end or another. One of the points that I want to make today is I'd like to organize a way within our system to create this, what I'm talking about, that doesn't require each front end developer to completely redo or assign himself the task of populating this database, of doing this stuff. Hopefully I can find ways to take advantage of the fact that we all are creating a kind of an abstract syntax tree or in the generic structures in gimple, and take advantage of that so that all of our languages automatically get all the benefits of what we're talking about. I'm not suggesting, by the way, that we're going to build all the tools on top of what I'm describing today. I'm hoping that we'll provide a foundation on which other people can build innovative ways to do this stuff. So the antique tool that I mentioned at the beginning, Digital Equipment cleverly called the source code analyzer. I used it in, 1995. It claims to be multi-language. I only used it for C. I'll get to that in a moment. But it does things. Yet today, you can get it from digital. If you've got VMS, you'll have a good tool. That nothing I use can do now. It includes a database of a certain kind, I'll talk about in a moment. It has a weird query language because query languages in 1980 weren't that great. It has a GUI, which is even worse, and I didn't use. I think interestingly, it has the chapter 2 of the manual describes a call interface, an API to talk to this system, and that API was used by DEC's editor. So that was the working interface. We might want to supply such a thing. I only used it for C. The GUI was of no use at all. But even though the query language was quite weird, as you'll see, it was great. I used it to port one system from VMS to, at the time it was called Daytona. It was the new version of Windows NT. And the only way it was a good way to extract the information about the system I was reading from and reproduce it in the new form. So I'm going to talk about how the SCA represents itself and talks about data, not as a way to reproduce, but just as an introduction to the problem. In everybody's source code, you've all got symbols. You have things that define stuff. They appear someplace. So those are definitions, or they're just tokens, right? The plus sign or whatever. Then those things are used in some place. That's another location, and they're used in a certain way. So from this system's point of view, you have symbols, you have an appearance of that symbol in some use somehow, and its relationship to other symbols. I think that's a bit too abstract for what we should be doing, but that's my database background speaking. Not but, and that's my database background speaking. You have, so here you have these abstract symbols getting attributes. So you can see they've got this sort of entity attribute value model of just not really defining anything specifically and letting all of these attributes define the thing for you. But it has all sorts of interesting features I found. Like, I don't know what inheritable is, but apparently it's something Ada wants. It deals with the fact that the thing is an include file or coming from an include file. It has this notion of being module specific, which is what we call static or file scope in C++. So we have places that things are defined and places that things occur that make their appearance in your code. We have things that are being read, things that are being modified. We have addresses that are being taken or dereferenced. We have things that are being called, sometimes indirectly. This system actually incorporates, will tell you about command line arguments and include file names. It'll tell you about base classes and distinguish between private and protected. All of that stuff, I'll repeat, is in the parse tree already. They captured this information and were able to query it. They were using what they had then. They were working on tiny systems, relatively small code bases with no free database technology of any kind. So they did what they could. I suggest we have better tools, we have better machines, and we have 30 years experience they didn't have. Sorry. I told David to come because I give him credit for locations in the diagnostic system, but that's all I really mean. In a moment, I'm going to show you the database design, but every token in your parse tree occurs at some place in some source code file. The triplet of the file name, the line, and the column describe every token in your system. And so all of the stuff relates back to that. That was my point there. The definition of functions and the calling of functions actually aren't related, right? Some systems, COBOL for one, can call functions that aren't named anywhere else except there.
I maybe that is not exactly what a location T is. If you're referring to the type location T when you refer to David Malcolm location, it's slightly richer than that.
Mm-hmm.
But I'll shut up now. But hey, you did mention my name.
I did.
It's like
I did, and I appeal to your knowledge. From my point of view, that I think it's important. One of the gentlemen I was speaking with about this idea earlier was concerned that if you call something that is defined in another file, how will the system we're talking about know anything about that other definition? And the answer is the database contains all the files. So the triple of the file name, the line, and the column tell you where you are. Yeah. But you're right, tokens have more information than just that, for sure.
Things going that you could also represent in terms of location information. But please move on.
Okay.
Yeah.
So as I say, the fact that when the invocation of a function and its definition, those are two different things. Formal parameters have a type by the syntax, at least in most languages, and block scope, right? Scope is very important in the languages I know. The actual parameters to a call, though, don't have any obvious type when they appear in the source code. They are often expressions, and those things have types eventually. Anyway, so let us look at the database diagram. I used to do this for a living, and I use a primitive tool for a complex problem. At the center of everything are the locations. Why? Because that's how everything gets to, that's the first thing you need to know. We have functions and they have formal declarations. Those formal arguments have types. The location of the formal arguments is the same as the location of the function. That defines its scope. Yes, David?
I just wanted to put a laser pointer because I'm having trouble following where you're going.
Oh, do I have a laser pointer? I don't have a laser pointer. Do I have a mouse? I have a mouse.
Oh, wonderful, yeah.
Okay.
Ooh, even better.
Yeah. So locations are at the center of the game. I walked over here to functions to point out that that most of these tables have a location as their key, and those locations are sometimes shared values, meaning that the location of the formal arguments is the same as the location value of the function, and that's how in this database you know that those arguments are constrained by that to that function. That's how you distinguish those formal variables from other variables that have different scopes. We have scopes. Scopes and types and expressions, these are all recursive definitions. In case you don't know, SQL these days, you can make recursive queries, so problem solved. I populated a database like this, not using GCC, sadly, but a database with this design, which I'm going to show you in a moment, to reproduce the queries from the example in the source code analyzer manual to show that we can use this technology to do what they did 30 and 40 years ago and what I wish we could do now today. I put this on the page. We can come back to it. I think it's difficult to study a diagram. I can also walk through it if people want me to give more detail. Move on then? I'm happy to come back to it. I could talk about that all day long. So my proposal, what I'm hoping you to join me in making possible, moving from if to when, is to use SQLite as a database to store basically the entire parse tree, everything we know about the program when it is compiled. To add a command line option just to produce this, kind of a dump sort of feature. It has been pointed out to me that not all the information I want is in the gimple nodes. Fair enough. Maybe we need better ones. Maybe we have to make some modifications to amplify what we have. I think from that, a simple idea would be to produce cscope using these technologies just as a way to demonstrate what can be done. I don't even think that's a big problem. What I did was I used Python Because why? It's easy. And there's a C parser in there that I've learned how to use. So I use the Python C parser to compile the example from the system source code analyzer database example in their manual and reproduce their queries as SQL. The database itself is 400 lines of SQL. The C code is 106 lines of C. It's not a very complicated program. I didn't try to reproduce those on your slides here. You could follow the URL that was earlier mentioned.
So do you mean the schema is 400 lines of
Yes.
SQL, and the database you're getting onto is, in terms of the instance data, is 476 rows in the various columns?
Yes.
Okay.
Yes.
Yeah, thanks.
Yes. Yes. So I take 106 lines of C and I produce almost 500 lines of metadata in the database. The project is not complete. You ought to think, in my experience, that the metadata are roughly 10 times larger than the source code. It's amazing how much information we actually compress into a program. When you expand it and write it out in readable form, that's how big it gets. Somebody is going to ask me, if it's not in this room, some other room, why in the world we would write to SQLite. So I thought I would answer that question. The reason is because you need SQLite in order to ask the questions, in order to answer the questions. So you got to get there somehow. And there's not much point in writing it out in some intermediate form and then recompiling it or somehow transferring it to a database. And also, if you do it that way, you'll miss errors.
No, I was going to say the modern flavor of is large language model.
LSPs have what amounts to a crude, not terribly secret query protocol over a network socket to a persistent compiler instance, which has other problems such as generally the entire database is in memory, and often you've got problems like how do you run the compiler? Well, you run make under a horrible program that ptraces make to capture the build commands, and then writes it out to a JSON file, which the compiler then interprets and then runs, and it's just disgusting.
Well, I think we should give them an award there for at least creating a complex tool for a complex problem, right? Okay.
Yeah.
Yes.
By the way, how long is this session?
This session is 60 minutes.
So 12:30. So
Yeah. And I hope not to use it all. I'd like to talk about it with you. But the important point I want to make is that when you define, if the compiler itself is writing directly to the database, then the database can constrain the errors, can prevent silly constructions from being populated in the database, right? So it will create consistency between the various systems that are populating that database. And that's the important reason. SQLite itself as technology, I think, is not something that GCC should be afraid to include. It's a public domain system. It's got millions and millions of installations, probably on your phone, and a very well supported system. So this is our first example. We are finding all the occurrences of a thing called a rig vector. On the left-hand side is the query as it appears in the source code analyzer manual that I referred to earlier. And this is their output because it was 1995. And so what they're doing is they're saying on these lines, 515, 544, 581, 588, a rig vector appears once as an argument, once as a variable definition, and twice being read.
What was the source language in the example?
C.
It's C.
C.
Which, yeah, I'm just baffled because it's lowercase in the find and it's uppercase in the results, and C is case sensitive.
It is indeed.
Which seems wrong.
Yep.
Yeah.
Right. I think the people who wrote that tool would say to you that our thing is language independent, and so we're distinguished. I don't know why they did this.
Maybe it's a case insensitive query.
It's possible.
Yeah.
It's possible. I don't remember.
Maybe
Yes.
You're
it's anyway. That's how they represent their result. In their example, along the left-hand column are line numbers starting from around 500. It wasn't. I didn't create a file from their example starting at line 500. I had one that started at line 1, but I built a little translation table. So in my counter example, you could say, at the right-hand edge is their original line number, which you can match up to the line number that's matching. So here, line 544 appears over here as line 544. So you can. So this is to make my audience convince my audience that the output that they're seeing is congruent with the output that I captured from their manual. I use, instead of these terrible translit whatever things, I can't imagine why they thought that was a useful name. Just the standard thing that we talked about in the diagnostics, right? Maybe I could even make it into, I don't know, JSON or something. And so with the same sort of notations, because these roles are captured in a database. So you can see the SQL I'm using just to do this one. Occurrences does not appear in the diagram you saw because it's a view. That's where the 400 lines of SQL went. So now we can constrain the question that we asked earlier. Instead of all of the occurrences of original vector, can we find just the ones that are declarations? Indeed, we can. And how do we do that? We say where the type is the declaration. Can we constrain just the read reference? Again, yes, we can. How do we do that? We say where the type is a read. The notion of primary is the function that we're talking about declared or defined in the system amongst the files that we're interrogating. So we can do that as well. In this case, what do we do? We say where the type is a definition. That's pretty straightforward. That's what they were looking for in this case.
I might point out that C23 is going to make this extra fun because, for example, you will be able to declare the same structure repeatedly in the same file, so things might have multiple locations for the definition. But that's just an extra table and another join.
Yes,
so.
That's right. Oh, we could constrain it according to which file it appears in. We could constrain it according to what function it appears in, perhaps, right? These are all captured in the database. The example that is in the manual is not very complicated because you're trying to, it's a tutorial, but all of it, as you say, all that information is right there.
So I was just, it's been a few years since I did SQL. Is the third column there, you're basically capturing the value of the returns column and the roll column and string catting it with a space.
Yes.
Yeah.
Yes.
Okay.
Yes. I'm not even sure that was a good idea, but yes, that's what I did.
Sorry, it was just like.
Right. This is actually. It's an odd thing. SQL's my favorite language, except for that it's not very good in some ways, and yes, the double bars are a concatenation operator. I really should have fixed this if I'd had more time. It'd just be as well to show that it's a function definition that returns an integer. That's all I was trying to represent. They have this notion of expand, and it means that we can go. So here, the previous slide, we said, show me the primary data, show me the things that are being defined. And they have this notion of, well, is there a bigger idea of define? Well, there is in our world where define and declare are you could have functions that are defined. We have the actual code body of the function, or declared, where we only have its name and arguments. And so this was Digital's version of how you ask that question. rather straightforward to define a view called primaries and simply query that. So we see 4 answers from them and 4 from ours, where we've got definitions and declarations and calls delineated. It's a big one, where we want to find all the variables they're being written to. So there's an occurrence. An occurrence is an appearance in the code someplace, not a definition. And I forgot why occurrence equal declare. I'm not sure what that refers to. But in any case, we have all the different variables in the program and the places where they're being written to. If we wanted to, of course, we could name one of them. Yes.
Is there any chance of actually for you to implement the SEA language instead of the SQL? Because to me it looks like way better.
So I would say to you that I'm actually not going to implement any of this.
Oh, okay.
No, but I mean this in a certain way. The answer to your question is yes, right? Maybe you like that language better. I don't consider myself a UI designer. So what I want to do is build the foundation, right? And provide you with the views that supply the answers of these things. Yeah. And then you, if a language designer, if you want to implement a query language that you think is better, or a GUI that you think is good, or whatever, do that.
But
right?
actually what I'm saying from the examples is that, I mean, when you look at this find expand, the SEA expression at the left and the SQL expression at the right, it seems to me that clearly your database is way more expressive.
Yes.
And that's why the expressions are more complex on the SQL side.
I do not expect you or me or most programmers to sit down and use SQL to find these answers. Yeah. I don't expect that. I do think that any tool that you use could be built on top of SQL to answer those questions.
There is something else, but one advantage of using SQLite for this, a rarely mentioned feature of SQLite, is it's got very powerful virtual table support. Queries to tables can invoke more or less arbitrary functions, which can do more or less anything you like to get the data. So this could talk directly to a language server, LSP server, possibly an existing one, and extract info about the actual program as it's being edited, and feed it straight back out to this for whatever tool you like. Whether this is worthwhile, given the number of things that read the LSP, I don't know, but this seems a lot more expressive than the LSP, so you might be able to sort of combine the best of both somehow.
My proposal earlier in the slide was to use this technology and hide all of this stuff underneath a cscope wrapper. Reproduce what cscope does, using, but where the cscope, new cscope.
But still available.
I'm sorry, you said?
I mean, well, sorry. What I'm saying is that clearly the interface at the left is more abstract than the one at the right.
Yep.
And maybe even more practical for most use cases, but still it's nice to have the one at the right too.
Yes.
That level access at the level of abstraction as well.
Yep.
Yeah. I mean, I was going to add there is an intermediate layer, which is that every time I see a SQL schema, I'm immediately thinking, ooh, can I have an object relational map for that in Python? Or,
oh no!
You don't like Hibernate type things, but basically, which is the, which is like, can I write, have some Python classes, for example, using, it's been SQL Alchemy, that's the one.
Yes.
So there's a Python module called SQL Alchemy that you basically teach it. You basically combine. You use decorators to tell your classes how to bind it to a database, relational database, and then you can write Python expressions, and it will auto-generate extremely complicated page-long SQL queries. Or you can write Python code and expressions, and it will turn them into SQL queries that will then auto-populate a graph of objects for you, of Python objects based on the query. So it's sort of.
I mean, to Jose's point, the reason cscope, I'll pick as my favorite example. The reason we're still using it is useful, right? And the 7 things you can ask about your application through cscope are the ones you want most of the time. my point is we can do all that quite easily, and that we could reproduce that in another form.
Just a note, I noticed there's a flinching when object relational mappings were mentioned. SQL Alchemy is not like these old style ORMs which fill your database with horrible garbage whenever you use them for anything. This thing, you feed the ORM a bunch of SQL, and it generates the objects for you. So it deals with the database as a human being would have done, the sort of thing. It doesn't mess your database up, and it gives you a nice Python interface on the other end.
So you'll be pleased to know I'm almost done. What I began by saying was that our tool environment is moribund. It's like these things, the tools I use every day haven't changed in 30 years. And I don't know exactly why it is, but I think it has something to do with the implosion of the whole industry and the abandonment of academic approaches to the work that we do. The biggest problem, don't ask me, the people that write these tools say the reason they haven't done more is that parsing stands between them and better results. We're doing the parsing. So if we're willing to undertake to make the information available to them, I think they will do the other part and make interesting tools based on a better foundation. So we could do that, and we could provide an example of it. I don't think that's a lot of effort. I think it requires some consensus, and I think this morning I heard I'm supposed to help drive consensus, so that's what I'm doing, trying to turn if into when. So let's make this happen, and don't make me do it as a COBOL developer. I'll do it, because if you don't help me, I don't know. But I want to do it for the whole of GCC. If I can convince you we should do it, then help me figure out how. Now we've moved from if to when. And then we'll reproduce an example and watch that snowball get bigger. Thank you for your time.
May I? Sorry, yeah. This may be a rehash of our conversation at dinner on Friday night. Several points. I really like it looks like you have is the code available on a public repo anywhere, by the way?
I will make it so.
Okay. So it looks like you have a really neat demo of the SQLite database being fed by, you were using Python ply, the Python Lex and Yak to prototype C parsing, whatever, and to generate the data, stuff it in a database, and this sounds like a great kind of back end on top of which an LSP server could be made. It sounds not trivial, but it's just programming to then implement the JSON RPC server side of the handle over the protocol in terms of, okay, I got this JSON request, turn it into a SQL query, send the results back. And I'm thinking, ooh, ORM, because I don't want to write the SQL query myself. And it's like, okay, take the LSP request, express it as Python, turn that into SQL, get the results back, send it back. So that sounds very doable. You didn't mention LSP in your slides, and I believe I have not used it, but I believe there's a big ecosystem around it, and so ClangD and the various IDEs, so maybe. And what's the thing? The other thing is historically. Within the GCC community, the founder of GCC was historically adamantly against exposing GCC's internal representation outside of the process, out of a belief that people would do an end run around the GPL. I think the hardware and what he wanted to protect, kind of the GPL-ness of the code by making it difficult to get at this sort of stuff outside the GCC process, or the CC1 or whatever. And so we sort of have this legacy of our internal representation is sort of hidden, and that attitude, I think, is long gone. I think we want to expose all this stuff, but unfortunately, because it's an almost 40-year-old code base, it's big. It's difficult to evolve. And I should shut up now and let someone else talk.
That's a good point, actually. I have a question for you, because, okay, this looks nice, and I'm very happy, actually, that you are working on this, and that you will continue working on this until something works. Thank you. And I am a little bit concerned about your source of information, though.
Source of information?
Yes, because there is already, I mean, gimple, you lower, from the different front ends. Okay, there are bad news and there are good news. The bad news is that gimple is, roughly speaking, GNU-C, right? You have nested functions, you have all the GNU extensions. So then when you are you know it well, you do the couple. So when you are implementing a language in a front end that has abstractions over the abstraction level of C, then basically you have to translate into the corresponding GNU-C, which is C plus the corresponding extensions, and that is your gimple. So you are generating the database from the gimple. Right.
Was my proposal.
Right, okay. So the good news, I think, because when I implement a module, for example, I may be implementing it with one function, which is the prelude, to initialize it, another function, which is the postlude. And if you get that from the gimple, the output, the abstractions you are getting, they don't make any sense to the programmer, right? But the good news is that there is already a multi-language semantic model in the compiler that we all front-end should actually translate into something meaningful, which is the DORF, is the internal DORF. And the DORF has provisions to be abstract enough so you can actually implement all sort of crazy front-end, crazy language abstractions. And the good news is that we have no choice. Actually, I don't know about you, but I'm having a hard time, deciding, So when new crazy programming language shows up and needs a new abstraction in DORF, DORF will evolve to actually try to accommodate that abstraction. So if instead of getting the information from the gimple, you get it from the internal DORF that in GCC uses, I think maybe you will get better results.
There'll be, I think David will agree, there'll be more information in the dwarf than there is. Yes.
Yeah, I was going to say, looking at the gimple is kind of, I was going to say that's the wrong thing to do. Well, it is the right answer to another question, which is like, an interesting question is, what is the optimizer doing to my code? Why doesn't this loop, did this loop get vectorized? And whatever. Which is a different talk. and gimple is great for that. It's like in the kind of it's the world of or at least the first 2/3 of the optimizer, as it were. And I think generic would be probably better for IR to be looking at for what you're doing, but probably even earlier. And I refer you to my Cauldron. I can't remember what year it was in Prague on the BLT. Prototype that was roundly rejected by the front-end maintainers. If I may, so I have some similar problems that I'm trying to solve in a Serif space, where, so for example, I have this prototype where Serif can capture in its file format has support for directed graphs, and so I have a prototype where I'm capturing the sequence of state of the control flow graph through the optimization pipeline for a translation unit, and you can see like when did this part of the IR get introduced? Which pass did it? Kind of thing is an interesting use case for that. Where was I going with this? But in terms of wiring that up, I have a coupling issue, which is that I have a whole bunch of diagnostic code that I want to keep independent of the fact that it's a compiler, it's GCC. No, I just want the idea that this is generic code that could be used for any tool that complains about things and outputs Serif and can have all kinds of interesting metadata inside it. versus here is the specifics of, say, the gimple optimization pipeline or the C++ front end, and I don't want the two to know about each other. So I'm thinking of playing around with a lightweight publish-subscribe framework, so that I can, for my use case, it would be, I want you might have a named thing which is control flow graphs, and then the Serif outputter might say, I want to listen for control flow graph notifications, and I have a handler for that. And then the optimizer might ask, are there any subscribers? Okay, if so, tell them I've got a new control flow graph state. And in the common case, that is a very cheap, if conditional very rarely holds, keep it, in terms of the common case, it doesn't slow down the compiler. It's a conditional that always fails, or and all of the handling for that can be in the cold part of the compiler. So you might have a similar use case where you say, okay, in the C++ front end, please, dear C++ front end, can you offer a channel of notifications I can subscribe to about the syntax tree?
Right.
Like, I'm beginning whatever the different productions and the grammar are, and I want to be told about, pushing and pops of nodes in the syntax tree, in fact, at the language level, which is higher level than the generic level.
It occurs to me as you're talking about that the dwarf information would not necessarily have scope information, would it?
Yeah, the problem with dwarf, if you look at LLVM, its LSP stuff is tied in right after the parser and not at the dwarf layer. The problem with the dwarf layer is that its job is to bind artifacts in the finished binary to source lines for the sake of debuggers. But we're not actually interested in the finished binary for this application. We're not interested in what's happened after the optimizers got into it. This thing's been cloned into a dozen locations. These things have been dropped entirely. We want the right after parsing information, and Dwarf doesn't have that, which is a shame because it doesn't really seem to be any location where.
I'm not suggesting him to use the dwarf, the final dwarf.
So if there's a dwarf before the optimizer gets it, if there is early dwarf.
In the early
It's
dwarf,
done right after parsing.
Oh, right, and that's useful.
and
Then.
in the early
I
dwarf,
didn't
you
realize.
also have access to the tree.
Oh,
And
yes,
actually
yes.
You can go to tree nodes from the.
That's
from the
useful.
guides, or
But,
the other way
yeah.
around.
Just don't be tempted to get it to just pull out the minus G output. That's not going to work.
It's early dwarf. It's an internal representation.
Yeah.
It's not the final dwarf that gets generated.
I see.
I also have a question, if I may. So one of the things about LSP, the protocol, is that language servers can declare their capabilities, right? So some language servers only have capabilities to introspect the database, so read from the source code, but others also have the capability to make changes to the source code. So they can propose quick fixes and rename all of the occurrences of a given variable. And I think with the SQL model, I think maybe it's a bit hard to do that because you have to keep the source code in sync with the database. But if we have like a pub sub system with the database, maybe there can be some kind of persistent, again, parser.
Becomes the pub subsystem. You could, if you were crazy enough, you could implement a scheme where doing an update on the database would modify the source code, because you can do anything in these functions. It would be madness, but you could, in theory, do it. It would literally be a connection between the pub sub LSP on one side and SQL on the other.
I think ultimately
what he says is true.
I think ultimately it depends on what we want the scope of this tool to be, right? And we need to architect around that.
Yeah, sorry, we spoke a lot of variable and function, which are kind of relatively easy to manage from the, at least from the linker, because we end up with symbol. But one of the most query kind of, I will do it myself kind of, is trying to understand where the fields are used. And one of the problem is that a lot of fields are the same name
Yes.
between multiple structures.
Yes.
And currently, yeah, how is
Yes.
it possible to the parse to do that? You know?
Oh yes, of course, because the parser knows, right, the names of all the members of each structure, for example, right, and therefore the owner of everything, and that's where these scopes come into play. So a variable lives at some scope. So the structure itself has one scope. The members are within the scope of that structure. You got some structure, foo, right? You got bar, whatever. So you are able, in using the variable names and the scopes. I didn't produce an example for you here, but you could ask for a variable according to what type it belongs to. Either the type it belongs to or the instantiation that it belongs to, right? You could ask it about the variable or the variable's type. Both of those things are features of the variable.
Just at the beginning of your slides, you had here are the existing tools and here's what you use. I just wanted to throw in git grep. I find very useful for dealing with GCC source tree because it's so fast.
Okay.
What? Whatever. But if you just want
I've never tried it.
doing a string search over the whole of the repo, git grep's, at least on my, it's really fast and it's a handy tool. I also
Does it understand anything at all except for the string?
No, it's just, that's just
It's a grep.
A more semantic thing would be Doxygen. And SUSE have a website where they do weekly docs, which has a public
Yes.
Doxygen thing that's, I think, updated every
Yes.
weekend from the...
For the benefit of those present, David and I spoke about this earlier, and Doxygen, my complaint about Doxygen is that it's a report, but it's not an interactive system.
Okay, last question.
Yeah, I'm really interested about this because 10 years ago, my supervisor made a huge mistake and did not implement a database for a tool that would use exactly this. So I'm very interested in talking to you over lunch to share notes. At the time, I think we basically dump all the information that the Clang AST provides. And we then do all these queryings and analyses that you talked about only in an academic project and without any consideration for performance. So we should talk.
Yes. I tried to do it with Clang once.
Yeah.
Yeah.
That is it. We have to finish here.
Thank you.